Good morning, students. In this lecture, we will discuss about the symbols that we are going to use for MOSFET and the capacitances associated with MOSFET. See, here you can find the symbol for both NMOS transistor and PMOS transistor. So, NMOS transistor is a 4-terminal device, gate, drain, bulk terminal and then source terminal. Okay, and this is the circuit symbol used to represent NMOS transistor, in which we can find one arrow mark pointing in the towards the outward direction in the source terminal. Now you observe the symbol for PMOS transistor. So PMOS transistor, it is also a 4-terminal device. So here also you can find gate, source, body terminal and then drain terminal, but the arrow mark is pointing towards the inward direction in the source terminal. But here source is placed on the top position. Why? What is the reason? Means source is having higher potential than the gate terminal, so it is positioned on the top. Okay, so that's all about the circuit symbol for both PMOS transistor and NMOS transistor. So now let us see about the capacitances. What are all the capacitances that exist in a MOSFET transistor? Okay, see, where a capacitance will exist means between any two terminals you can find one capacitance. Okay, why you are giving importance to capacitance, or why you are taking into account capacitance means, in order to predict AC behavior of a particular device, you should take into account the capacitance associated with the device, and the value of this capacitance depends on the bias conditions of the transistor. Okay, now you observe this figure 2. Okay, I already told that capacitance exists between every two terminals. So now you consider drain terminal and gate terminal. So in between gate terminal and drain terminal you can find one capacitance denoted by CGT, that means capacitance between gate and drain. Now you consider the gate terminal and then source terminal. So in between these two terminals you can find one capacitance denoted by CGS, that means capacitance between gate terminal and source terminal. Now you consider gate terminal and bulk terminal. So in between these two terminals also you can find capacitance CGB. Now you take the source terminal and then bulk terminal. Here also you can find the associated capacitance denoted by CSB, which indicates the capacitance between source terminal and bulk terminal. Now you take these two terminals, drain terminal and bulk terminal. Here also you can find one capacitance existing between the drain and bulk terminal denoted by CDB. So between every two terminal for this particular 4-terminal device you can find one capacitance exists between every two of those terminals. Okay, now we will see the capacitance associated with MOSFET considering the physical structure of the MOSFET. Okay, so this is your physical structure of MOSFET. As usual, this is an NMOS transistor. So source, drain both are heavily doped, fabricated on a P substrate. Here you can find the gate. Okay, now you find the associated capacitance. See, here you can find one capacitance C1, which is the oxide capacitance between gate and then channel. What is meant by channel? Channel is nothing but it contains charge carriers. Since it is an NMOS transistor, charge is carried only by means of electrons. So this channel includes electrons and the current flows one from source to drain because of these electrons only. So C1 denotes the oxide capacitance that exists between the gate and then channel. Okay. Next you move on to C2. So this is your depletion capacitance between the channel and substrate. Then here you can find one more capacitance C3. Why is this capacitance exist means because of overlapping. You can find that at this particular portion you can find gate overlaps with the source. So due to this, the capacitance exists between gate and then source, which we call it as overlapping capacitance. Then next one, C4. C4 also exists only due to overlapping of gate with drain. Next we move on to capacitance C5. So this capacitance is the junction capacitance. This capacitance exists due to capacitance between source or drain and substrate. Are you able to understand the concept? C5 and C6 both are junction capacitance that exist between source and substrate or drain and substrate. So these are all the mass capacitances that you should know before entering into threshold voltage. Thank you.